Welcome to today's lesson on the algebraic representation of scale factors. So we are working with dilations today. I'm going to go ahead and share my screen. Okay, so our TEK for today is 8.3c. Our lesson target is I will use an algebraic representation to explain the effect of a scale factor applied to two-dimensional figures on a coordinate plane. Our essential question is, how do you know if a dilated shape is enlarged or reduced? Okay, so let's break down that lesson target. An algebraic representation just means a math rule. Scale factor. We use the letter K to represent scale factor. And yes, again, scale factors pertain to dilations. Only dilations out of the different transformations use scale factor. Okay, so how do we know if a shape is enlarged? Well, we know that the scale factor, or the K, is going to be greater than 1. And then how do we know if it's reduced? Well, the scale factor of the K is going to be less than 1 in that case. We have some vocabulary words: corresponding sides, corresponding vertices, similar figures, congruent angles, proportional figures, dilation, algebraic expression or rule, origin, center of dilation. Okay, so an important thing to know is that corresponding sides on similar figures, as you can see, I highlighted that in the green. I'll go ahead and do that again. So this corresponding side to this corresponding side. And then I'll go ahead and highlight another corresponding side in blue. So this corresponding side to this corresponding side. If we did new over old, so let's say the shape got bigger, right? So our new would be the bigger length. So let's say we started with the green. If we took the green length, the bigger length for the green, and put that over the smaller length of the green, whatever that number would be equal. You can see that A prime has also been graphed. Problem number 3 says plot point B prime and C prime on the coordinate plane in the worked example. So then A says point B to point B prime. So before we can plot anything, we have to write our algebraic rule for this problem. We know that all of our transformation rules start off with x comma y, and we know that since our scale factor is 3, our rule is going to be 3x comma 3y. So to figure out what B prime is, we first have to figure out what B is, right? So B right here is at 3 comma 3. So then if we look at our rule, we have 3x. We know that a number and a letter together means multiplying. So we're going to be multiplying. So that means that in dilation, because we have numbers next to letters, we're going to be multiplying. So we're going to multiply both our x and our y by 3. So 3 times 3 is 9. And then 3 times 3 again is 9. So that means that B prime is 9 comma 9. Then I'm going to go ahead and switch and find out C and C prime. So we have C is right here, and that's at 4 comma 1. And then C prime, again, we have to multiply both numbers by 3. So 4 times 3 is 12. 1 times 3 is 3. So we have C prime is at 12 comma 3. So then we have to graph 9 comma 9 and 12 comma 3. So to graph 9 comma 9, I'm going to start at the origin. I'm going to move 9 units to the right and go up 9 units. So that is B prime. Then for C prime, 12 comma 3, I'm going to start at the origin, move 12 units to the right. So even though it's not labeled on here, I know that after 11 is 12 since we're counting by ones. And we're going up 3 units right here. So that's C prime. I'm going to go ahead and connect the dots to make my triangle. And I can see that my scale factor was bigger than 1, right? So that means my shape got bigger. And now I can visually see that from A prime, B prime, C prime. So now question 4 says draw triangle A prime, B prime, C prime on the coordinate plane in the example. We already did that. Is triangle ABC similar to triangle A prime, B prime, C prime? Well, we know that similar figures have the same shape but different sizes, which is the case here. So yes, it is similar. It is not congruent. Okay, the next question or the next part is dilate triangle DEF by a scale factor of 1/4 using the origin as the center of dilation. Point D is translated from the origin 4 units to the right and 4 units up, 4, 4. This is the same as 4 translations of 1 unit to the right and 1 unit up. Therefore, scaling point D to 1, 1 represents dilation by a scale factor of 1/4. So again here, it's just relating translation to dilation. We are going to start by writing our algebraic representation, which always starts with x, y. We know our scale factor is 1/4, so we're going to go ahead and write the 1/4 x, 1/4 y. So we can see that DEF has already been graphed, and so has D prime. So we obviously have to figure out E, and then E prime, and then F, and then F prime. So let's start with E. E is located at 8, 8. And then we know that, again, we're going to be multiplying 8 times 1/4. So remember that when you have a fraction is the same thing as division. So fraction means dividing. So 1/4 is going to divide. So yes, I could do 1/4 times 8, or I could do 8 divided by 4. And 8 divided by 4 is going to be 2. So again, 8 divided by 4 is 2, so that means that E prime is at 2. Then I'm going to do F. We have F is at 12, 4. And then I have to figure out the location of F prime. So again, we're going to divide both x and y by 4. Divided by 3. 4 divided by 4 is 1. So now I have that E prime is at 2, F prime is at 3. Starting at the origin to graph 2, so 2 units right and then 2 up. So here, I'm going to label that E prime. Then to graph F prime, 3, right, 1 unit up is F prime. I'm going to connect the dots to make my triangle. And we have to confirm that since our scale factors are full, we know that our shape got smaller. And we can see that right here, that it got smaller. So to answer question 6, triangle DEF similar to... Yes, it is, because they are the same shape but different sizes. I'm going to go ahead and write the word similar in here. Then to answer question 7, it says, how does dilating a figure using the origin as the center of dilation affect the coordinates of the original? So how does dilating a figure change it affect the coordinates? What this question is. Well, we know that from the first part of the example, our coordinates got bigger. Then from this last example we did, so it affects the coordinates by making the new coordinates either bigger or smaller. Okay, next we do. It says triangle ABC was dilated with origin as the center of dilation to create triangle ABC prime. What is the algebraic rule applied to triangle ABC to create triangle A prime, B prime, C prime? Well, looking at the two shapes, we see that there's A prime, B prime, C prime, so we know that the shape got smaller. So going to shade that in or color it in. So if I know that the shape got smaller, I'm going to go ahead and write that. It got smaller. So that means that our scale factor has to be less than. We are using the new over old rule. So I have to find 2 letters for corresponding side, that will work. So what I mean by that is that letters that are the best are ones that are on the corner of the grid. It's easy to tell the coordinates, the ordered pair. So A is a good point, but A prime is not because it's hard to tell the coordinates. B prime and B are good points. C is a good point, but C prime is not. So we're going to go ahead and choose B and then B prime. Okay, so B is at 8, comma, -4. And then B prime is at 4, comma, -2. So I can either choose my X or my Y coordinates to focus on. I'm going to choose my X coordinates just because I know that with negative numbers, sometimes that gets confusing for people. So I have to figure out what is my new, what is my old. So my new is going to be the number next to the prime, right? So that was the 4. Then my old is going to be the 8. So 4 out of 8 we can see is not in simplest form. So we actually have to figure out how to reduce it. So the way I like to teach that is to think about the factors, the numbers that multiply together to make each number. So what numbers multiply together to make 4? That's 2 times 2. What numbers multiply together to make 8? That's 4 times 2. But I know that 4 can be broken down into 2 times 2. So here, I'm going to cross out the numbers that are the same on top and bottom, which is 2 and 2. And so on top, we're left with no numbers. So I'm going to write a 1. On bottom, we're left with 2. So that means that our scale factor is 1/2. But we're not done yet because we need to go ahead and write the algebraic representation or the rule. So we know that all of our rules start with x comma y. And now I just need to put the scale factor back in. We have 1/2 x comma 1/2 y. Okay, now we're going to do another we do. So for this problem, it says triangle ABC was dilated with the origin as the center of dilation to create triangle A prime, B prime, C prime. What is the algebraic rule applied to triangle ABC to create triangle A prime, B prime, C prime? Well, looking at the picture, we can see A prime, B prime, C prime. We see that the shape got smaller. So I'm going to go ahead and write smaller. We see that K is less than 1. And so from here, we know that we're using the rule new over old. And we had to find 2 points that'll work. So corresponding points, right? So in this case, we have A and A prime both work. We have A prime. Okay, so A, I'm going to say is at 8, comma 4. A prime is at 2, comma 1. So I can either choose my X's or my Y's. So I'm going to go ahead again and choose my X's. So our new number is going to be the one with the prime, so that's number 2. Our old number is going to be the 8. And of course, now we have to simplify because 2 out of 8 is not in simplest form.
Good afternoon, teachers. Please, this time, dismiss all bus riders.
Okay, so then I'm going to go ahead and list out the factors of 2. So the numbers that multiply together to make 2, and that is going to be 1 times 2. Then I have to list out the factors of 8. So that's 4 times 2. So 4 can be broken down into 2 times 2. So from here, I'm going to cross out the numbers that are the same on top and bottom, which is the 2. So that leaves me with 1 on top and then 2 times 2 on bottom, which is 4. So that means that my scale factor is 4. And of course, I have to finish off by writing it in the algebraic rule. So we have x comma y to 1/4 x comma 1/4 y. And the rest of the problems are you-dos and independent practices. Thank you so much for following along in today's lesson, and see you in the next one.